All right, so yesterday we had that homework problem. I want to go over the answer to that one. There were basically three answers I saw, one of which was correct. The other two were pretty consistent. They were somewhere in the 10 point something range and 51 to like 53. Now, I believe the reason for both of those are errors in the early on calculations. So for F3x and F3y, I believe that's where a lot of people had issues with, is that F3x is opposite to the angle theta there. So you're not using cosine for x, you're using sine. Now F3y is now adjacent, so that is the one used the cosine function for. So I believe a lot of people were flipping these answers, the 7.61 and the 16.31. The other bit is in the net force in the x and the net force y calculations. I think people were just going and adding those values straight across. They weren't considering what direction they were in. So the 22 should be negative and the 16.31 should be negative. So just to quickly walk through those steps, you start off by diagramming it, breaking it into its components. So you get the F1x, the F1y, the F2x, the F2y, which isn't there because F2 is directed along the x-axis. There is no y component. And F3, you have the x and the y. So the values for those are up here in this top left-hand quadrant. Just check and make sure you get the same values for that I did for those. After you get that, you want to figure out the net force in the x direction and the net force in the y direction. So the net force in the x, you want to sum up your fx's. F1x and F3x are in the positive direction, so they are positive values in that equation. The F2x is negative, so that means it's a negative 22 in there. So that comes up with a negative 0.25 newtons as the overall F net in the x direction. Then go do the F net in the y. So that's the sigma Fy equals F1y, 2y, 3y. 1y is directed upward, so it's a positive 14.14. 3y is down, so it's a negative 16.31. The overall F net y then is negative 2.18. After getting the components to the net force, you can find the total net force. That's the bottom left-hand quadrant. Draw that out. Negative 0.25 to the left, negative 2.18 down, your total being from the start to the finish, so that is the one in red. To calculate that, you've created a right triangle with your components. You can go ahead and use the Pythagorean theorem. Doing so, you should get a total net force of 2.19 newtons. After that, you need to get an angle, a direction to it, because force is a vector value. It needs to have a magnitude and it has to have a direction. The magnitude, the amount, is the 2.19. That is the strength of the force. Now you need to know which way it's going. So you use inverse tangent. You could also use sine or cosine. I tend to stick with tangent. It's just my personal preference. And that is Fy over f of x. That comes out to 83.46 degrees. Again, sine, cosine are good because at this point in time you have all three sides to that net force triangle. Just make sure you're using the right values for the right trig functions. So if it's cosine, using adjacent hypotenuse. If you're using sine, opposite hypotenuse, tangent, opposite over adjacent. Now your final answer, you could state it as it's 2.19 newtons at an angle of 83.46 degrees below the negative x. That's going to tell me where it's at. You could also use it as an overall value for the angle. We know the positive x-axis is 0. Positive y is 90, negative x is negative 180, negative y is 270. So to get the answer, this net force is down here and to the left. So the answer would be 180 plus 83.46. So 263.46 degrees. So that could be an answer as well. 2.19 newtons at 263.46 degrees is the net force. Both are viable. It's up to you which one I want to do. Just make sure you specify which one it is when you provide your answer. Now from here on out, go check out the other stuff on Google Classroom, and I will talk to you in my office hours if you happen to stop by. Have a good one.